Hello, Earth Science students. This is Miss Snook. I wanted to thank you again for seeing you today and going over the quiz. I hope that you will review those questions that I posted in the Google Classroom about the quiz and the notes that I made for each of them. I also made the corrections to the quiz, so your grades have changed, so you can go ahead and review that. We are going back to the Google Classroom this week, and you're working on the scale model of the motion of the solar system, which we have been trying to do in class, but you're going to do it online. And you're also going to do a slide show of what is wrong. I believe I have 3 pictures on this slide presentation in Google Classroom, and you will look at the pictures very carefully and critically and list what is wrong with them. When you're done with that work, there are 3 videos here I'd like you to watch, and the sub can show those to you on the main screen. I would like to go into the movement of our solar system so that you have an idea of what the math looks like. You are comparing the other planets' movements to the Earth and to a clock, a 12-hour clock. And the way that I have these proportions written up here, you're going to just repeat these proportions with the data for each planet. And then you're going to draw a circle using the drawing tool that is up here, and a circle for wherever your planet lands. So this is Mercury after 1 year compared to Earth. And I need to fix that. That shouldn't say. Yeah, okay, 1 year on Earth. Anyway, so 1 revolution of Earth is equal to 365 days. This is Mercury's ratio compared to Earth, so it takes about a quarter of the time to go around the sun that it takes Earth, so it goes faster. This X represents the number of days that means. So if you do the cross multiplication, you will find out that it takes 87.6 days for Mercury to go around the sun 1 time, which means Earth still has only made it around a quarter of that time. Let that sink in, look at the numbers, and let it make sense to you. I've written an explanation of what that means down here and how to move on from that number. So it says it takes Mercury 87.6 Earth days to make it around the sun. 87 is equal to the 12 on this clock over here. So 87 times it's going to reach that 12. It has gone around the sun that many times. So you have to deal with the 0.6. That is what is important here. So you're going to take that 0.6 and you're going to multiply it by 12 to find out where it ends up on this clock. And if you do that, you'll get 7.2. So go ahead and put that in your calculators right now. Make sure when you take 12 and you multiply it times 0.6, you get 7.2. I'd like you to round down to 7. I'm not going to have you go crazy with the decimals. If it's above 5, round up to the next hour. If it's at 5 or 6 or 7, you can do the half hour. And you will make your dot on the Mercury's orbit, which is the first orbit from the sun, at approximately 7 o'clock. So this red dot that I have here matches where 7 o'clock is here on the clock. And that's how you do this. You are also going to take a look at this slideshow, which is what is wrong. There are 3 images here, and you will look critically at those images and type in the blank spots what is wrong with those images. If you have misplaced your planetary fact sheet, that is also located in the Google Classroom here towards the bottom, so please make sure to get that. I'm not printing out anymore. And like I said, if you get all of that done, there are 3 videos for you to watch, and I will see you on Friday.